Okay, so hi everyone. I am Emily Saurette and welcome to my 3 Minute to Impact presentation. I work here at CNL in the Environment and Waste Technologies branch, and part of my job is to understand groundwater contamination. So the groundwater that's stored in the aquifers beneath our feet is a very important resource here in the Ottawa Valley. You can see in this map here, all of the people in this area use in 1 year 13.6 thousand megaliters of potable groundwater every year. To put that amount of water into perspective for you, if everyone who worked at CNL drank one extra large Tim Hortons coffee every second of every working hour of every day, we would use the same amount of water. That's a lot of coffee and a lot of water. But what happens when that water becomes contaminated and we can't use it to make coffee anymore? Well, we get a groundwater plume. The groundwater contamination moves through the unsaturated zone and hits the groundwater and becomes a dissolved phase plume that moves in the direction of groundwater flow. Well, hydrogeochemists are extremely creative people, and so they came up with the idea to suck out the contaminated water using a pumping well and treat it above the ground. Well, this is a physical remediation method, and it relies on removing the contaminated water and treating it after. So that can be decreased in efficiency as the contaminant concentration also decreases. We have many scenarios where we have inefficient pump and treat systems. But that's not the end of hydrogeochemists' creativity. They thought to cut out the middleman of the pumping well and install a permeable reactive barrier. I like to think of permeable reactive barriers here as a big brittle water filter that's installed in the ground. So the contamination will move through that filter and come out the other side treated. These, though, however, are often put into place with trenching and large equipment that is needed to put in the reactive material. That can be time-consuming and expensive. And so we can do something kind of innovative with injectable permeable reactive barriers, where we use a drill and a rod that is perforated to emplace the reactive material as a slurry. This has been a really flexible groundwater remediation strategy that I personally used in my previous employment, and we would use this and inject through the basements of buildings. We could target specific fractures in groundwater and bedrock aquifers, and we could also do this kind of injection where we were doing it at a gas station or a dry cleaners in a strip mall, and we could have the other businesses still operational while we were doing the remediation. So I want to thank you all for taking the time to learn a little bit about some solutions to pollution that aren't dilution.